the cubic y is equal to kx cubed minus k plus 1x squared plus 2 minus k x minus k has a turning point that is a minimum when x is equal to 1 precisely for one of these options for k. All right, so my thought here is to simply start taking some derivatives of this expression with respect to x and enforce the fact that we have a turning point when x is equal to 1, meaning that the derivative is 0. That'll give us one condition for k, or it'll give us some equation with k in it. And then also, because it's a minimum, we know that the second derivative with respect to x should be positive. It'll probably be positive, right? If it's 0, we'll have to think about other things to do. But if the second derivative is positive, that'll give us another condition that we can enforce for k. And then combining these things, see if we can come up with one of the options that's below. Okay, so the first thing I've done here, I've taken this first derivative and then substituted x equals 1 and set that equal to 0. And when I solve for k, I find that, in fact, all values of k make this true. The left-hand side here simplifies to 0. Everything cancels. And so the first derivative is always equal to 0. So we don't have to worry about values of k where this is or is not a turning point. But we do still want to imply or enforce the condition that the second derivative should be positive. Okay, so I get that k has to be greater than a half. I mean, technically speaking, in general, the second derivative could be equal to 0, and we could still have a minimum. But because it's only a third degree polynomial, that won't actually happen. You would need a fourth degree polynomial for this to happen, I think. And this corresponds to one of the options that's given. This is option C. So pretty confident in this one. Nothing too special going on. Yeah, I don't have much more to say about this. But translating the information given into the mathematical statements was pretty much all that went into this one. Thanks for watching.